In this video, we're going to find the critical points of a function, and the critical points should be in the domain of the function. So let's look at the domain of this function first of all. So this is going to be all x, where x is greater or equal to 0. And the thing is, you could write this as, but I think it's inconvenient, but you could write this as x to the 1/2 minus 3, x to the 2/2, x to the 1/2. So this is x radical x minus 3x squared radical x. And my point is that, the reason I would do that is just to make it clear to everybody that we are taking a square root. So you can't take a square root of a negative number in the real, if we're looking at real value functions. So that's why I'm saying the derivative is all x where x is greater than 0. That is definitely not something that we need to do write down. So that's a little aside. But what I'm going to do here is I'm going to find the derivative, and I'll just use the power rule. So I get f prime of x is equal to 3/2 x to the 1/2 minus 3 times 5/2 x to the 3/2. Now, the domain of f prime is exactly the same. It's all x greater or equal to 0. So it's true, for example, f prime of -1 is undefined. And if you recall, a critical number is a number where either the derivative is equal to 0 or the derivative is undefined, okay? So f prime of -1 is undefined. However, -1 is not a critical number because -1 is not in the domain of the original functions. So in terms of f prime being undefined, we're looking for numbers where f prime is undefined, a number where f prime is undefined, but f is defined at that number. And there's no cases for this one. So there's no critical numbers. So f prime is defined for x greater or equal to 0, which is what I wrote over here on the right. The domain of f prime is x greater than or equal to 0. So there's no critical numbers where found by taking f prime of c, and f prime of c ends up being undefined. Like I said, f prime of -1 is undefined in terms of a real number being a real valued function, but -1 is not in the domain of the original function. Okay, so what we're going to do is we're going to solve f prime of x equal to 0. It could turn out that, actually I'm wondering now, it could be that actually there's no solution to that. Now, the f prime of x equals 0 is those values which would be critical numbers, if there are solutions to that, are going to correspond to horizontal tangent lines, and there's no guarantee that we're going to get that we're going to have a horizontal tangent line, especially if it's an increasing function. But all right, so this is f prime of x. I'm copying that from above, and I set that equal to 0. And so I suppose I need to really think about what I'm doing here. So I'm going to factor. That's my tool, which is usually the tool that people use when they're solving an equation, when they, finding the roots of an equation, where you set it equals 0 and solve. I see that 1/2 is a common factor, and I see x to the 1/2 as a common factor, and that leaves 3 minus 15x. And here I have x to the 1/2 equals 0, which squaring both sides gives x equals 0. And then I have 3 minus 15x equals 0, and that corresponds to 3 equals 15x, or x equals 3 over 15, which is 1/5. So actually this problem was pretty quick. I was sort of bracing myself for something more challenging. Well, that's assuming I got it right. But anyway, these are the critical numbers. Okay, so the critical numbers are numbers that are in the domain of the function where either f prime of that number is equal to 0 or f prime of that number is undefined. So let's just do a little remark. A number C is a critical number of f if C is in the domain of f. I should make this bigger. So, but I sort of want you to see the stuff that came above. But it's in the domain of f, but either, not but, and either f prime of C is undefined or f prime of C is equal to 0. That's really not just a remark, that would be a definition. Now, I'm saying critical number. The problem actually said critical point, but I'm saying it's a critical number, and I just give an x value. Now, it wouldn't surprise me, actually, if the Openstax book might say, well, actually, I want to get the y value also. But I'm just giving the x value. But if I were, I don't know, maybe just to be careful, I could put in x equals 0 and find the y value, and x equals 1/5 and find a y value. It would be quite a bit of trouble, actually, for putting in x equals 1/5. But I'm going to stop here and say that I got it right. Okay. Well, maybe after I look at the video, if I review it, but maybe someone else just review it for me. But maybe I'll see I made a mistake or something, but I think it's good. Okay, so that finishes that. Goodbye.